Good day, I'm Daniel Hernandez and I will present to you the statics of rigid bodies. Here's a quick introduction about engineering mechanics. Engineering mechanics is the study of forces that act on a rigid bodies and the resultant motion that those bodies experience. The rigid body is defined as a definite amount of matter, the parts of which are fixed in position relative to each other. Statics. The effects and the distribution of forces on rigid bodies which are and remain at rest. Dynamics. The motion of rigid bodies caused by the forces acting upon them. Lesson 1. The forces and components. Forces is any arrangement where two or more forces act on a body or on a group of related bodies. The characteristics of forces are magnitude, direction, and line of action. Principles of transmissibility. Principle of transmissibility states that the point of application of a force can be moved anywhere along its line of action without changing the external reaction on a rigid body. The components of coplanar forces. The components of coplanar forces can be solved either by the use of trigonometric functions or the use of slope. And here is the formula where you can use to solve the coplanar forces. The SOHCAHTOA, which is the sine theta is equals to opposite over hypotenuse, and the cosine theta is equals to adjacent over hypotenuse, and the tangent theta is equals to opposite over adjacent. Here is a given example that says solve for x and y components. As you can see, we have here our x and y components with line of action and forces 2008 kN pointing upwards to the left with 60 degrees slope, and 527 kN pointing downwards to the left with 30 degrees slope, and lastly the 115 kN pointing downwards to the right with a slope of the opposite 3 and adjacent 4, and we have to find the hypotenuse, which is the given formula here. Hypotenuse is equals to square root of 3 squared plus 4 squared. Then our hypotenuse is equals to 5. The first step is we should draw first our free body diagram for force 2008 kN, which is the line of action is pointing upwards to the left with 60 degrees where it is in the side of y-axis. For 2008 kN, our fx is negative 2008 sine 60 since the line of action is to the left and our 60 degrees is at the y-axis. So the answer is negative 1738.979 kN. Our Fy is 2008 cosine 60 because the line of action is upwards for y-axis. Then the answer is 1004 kN. And for the force 527 kN, our free body diagram with the line of action pointing downwards to the left with 30 degrees, our fx is negative 527 cosine 30. It is cosine since it's in the side of x-axis, and it is negative because the line of action is pointing to the left. So our answer is negative 456.395 kN. And our Fy is negative 527 sine 30. It is negative because it is pointing downwards. So our answer is negative 263.5 kN. And lastly, for force 115 kN with the line of action pointing to the right downwards with the slope of 3 and 4, we have to find the hypotenuse with this given formula. The given formula is the square root of 3 squared plus 4 squared is equals to 5. So, our fx is 115 times 4 over 5 since the x-axis is 4. Then our slope is, or our hypotenuse is 5. So, it is 4 over 5. So the answer is 95 kN. It is positive since the line of action is to the right, so it is positive. Our Fy is negative 115 times 3 over 5. It is 3 since the y is 3. Then it is negative since the line of action is downwards. So our Fy is negative 69 kN.